In the late 19th century, American paleontologist Edward Drinker Cope declared that no dinosaur could possibly have been able to fly. Yet just a few years later, fossil discoveries in western U.S. states like Wyoming proved him wrong. They uncovered bones from a group of dinosaurs with hollow bones, feathers, and long, stiff tails that were uniquely adapted for gliding through the air. But while the discovery of these fossils revolutionized our understanding of dinosaurs, there's still a lot that we don't know about them. What did they eat? How did they fly, and why did they evolve to glide? Hi, it's me, and this is my channel. Today, we are going to talk about the Jurassic Sky, because even though we now know that dinosaurs did take to the skies, we still have a lot to learn about the first flying dinosaurs, or maybe more accurately, the dinosaurs that could fly. The animals we're talking about today belong to a group called the Pterosaurs, which is derived from the Greek words for wing and stone. But not to be confused with the mythical creatures of the same name. These flying reptiles lived alongside dinosaurs between 225 and 66 million years ago during the Triassic, Jurassic, and Cretaceous periods, with their fossils being found across every continent on Earth. And they were pretty diverse too, with the smallest only being about the size of a squirrel and the largest boasting a wingspan comparable to that of a jumbo jet. But early in the story of these magnificent creatures, there seems to have been a bit of a gap. Fossils from the oldest known members of the group tell us that they were living on land around 225 million years ago in what is now southern Africa. And then a few million years later, they seem to have suddenly vanished. And that has left scientists wondering where did they come from and how did they evolve the ability to fly. So to find out how these iconic prehistoric creatures took to the skies, researchers are studying some of the very first dinosaurs to do so. And they are starting with the basic anatomy, specifically their bones. Because compared to other dinosaurs, the earliest flying dinosaurs had skeletons that were relatively light and flexible, which makes sense since you need to be lightweight to fly. In fact, their bones were about 30% lighter than those of modern birds, which are some of the best flyers on the planet today. But another thing that's weird about their bones is that they look kind of reptile-like. Their bones have a hard outer layer like modern reptiles and birds do, but they also have a spongy inner layer that looks a lot like that of mammals, which was previously thought to be a characteristic unique to birds. These adaptations suggest that these dinosaurs weren't very big. One of the lightest dinosaurs ever discovered, the Microraptor weighed less than 2 pounds, or about 1 kilo. And fossils tell us that it looked like a mix between a bird and a lizard. It had the head of a velociraptor, the body of a sparrow, and the tail of a feathered dinosaur called a Sinosauropteryx. And 2 limbs on each side of its body were turned into wings. And these findings hint at how these dinosaurs evolved to fly because back in the Triassic period, before birds existed, many small proto-bird dinosaurs were gliding through the air using flaps of skin that stretched between their forelimbs and bodies. These guys basically looked like squirrels with wings. So it makes sense that the ancestors of the first flying dinosaurs were small, feathered, and terrestrial dinosaurs that used gliding to help them hunt for food. And this may have given them an advantage over their relatives who stuck to the ground. After all, being able to glide would have made it easier to spot prey and get to it before your competitors, and it would have let them escape predators if needed. But there's one major problem with this hypothesis. The earliest dinosaurs were much bigger than these gliding dinosaurs, which means that evolution somehow had to miniaturize them in order for them to start flying. And scientists are still working to understand exactly how this happened. But recent research suggests that they were likely evolving under pressure from competition and predation. As new predators arrived on the scene, dinosaurs that were better adapted to escape had more offspring, causing the population to evolve more quickly. And in this case, the adaptation was getting smaller. In fact, studies show that this trend of miniaturization was happening all over the world at the time, with lots of different species becoming smaller. And at some point, some of these small dinosaurs grew feathers and turned their front limbs into wings, eventually leading to the emergence of the first flying dinosaurs. So we know that they were small, but what were these dinosaurs eating? Well, not surprisingly, they were probably eating insects. Even the biggest flying dinosaurs ate mostly insects, and they caught them in the same way that modern birds do, by soaring around and waiting for the perfect moment to dive down and snatch their meal. But this isn't the whole picture, because this strategy requires a lot of energy, which means that these dinosaurs probably needed a nutrient-rich diet, and research shows that they were most likely carnivorous. One study published in 2024 used computer modeling to determine the diets of some of the earliest flying dinosaurs. Researchers built virtual models of two extinct animals and their close relative, the modern red-throated bee-eater, which has a diet similar to the extinct animals. Then they compared the nutritional demands of these three dinosaurs against the amount of nutrition available in the plants and animals that they potentially ate. And they found that to meet their energy needs, the ancient dinosaurs would have had to eat more than 7 pounds or 3 kilograms of meat per year. This would have required them to be active hunters, which goes against the idea that they were gentle insect eaters. And in fact, researchers concluded that hunting behavior was a critical factor in the evolution of flight among these dinosaurs. And it raises more questions, like did these dinosaurs evolve the ability to fly in order to become better hunters? Or were they already hunting and then evolved to fly in order to escape predators? Well, based on what we know about modern birds, the answer is probably both. In fact, evolutionary biologists peg hunting as one of the main reasons for the evolution of flight in birds today. And they use a concept called optimal soaring theory to explain how hunting could drive the evolution of flight. Basically, this theory says that in order to make the most of their energy, birds should soar around at high altitudes where they can cover large distances while searching for food. But the researchers behind the study argue that the ancestors of flying dinosaurs were hunting on the ground. And while it's hard to say how the evolution of flight changed this behavior, it seems to have maintained the importance of hunting in their lifestyle. And they say that this is supported by anatomical features like the shape of their skulls, teeth, and limbs. But while we've learned a lot about the ecology of these creatures, scientists are still working to figure out exactly how they flew. We know that the earliest flying dinosaurs lived in what is now western North America, and they had long, stiff tails that acted as rudders to steer themselves in the air. But we don't know whether they used their limbs as wings to flap their way through the sky, or if they used gliding membranes to catch thermals and stay airborne. And that's part of the reason why one of the best preserved fossils of one of these dinosaurs was such a big deal. The fossil was unearthed in northeastern China in 2018, and it comes from a group of flying dinosaurs that lived during the Jurassic period, more than 200 million years after the first flying dinosaurs appeared. And unlike most other fossils of these creatures, this one had a complete skeleton. And one of the most interesting things about this fossil is that it revealed a membrane connecting the dinosaur's arm and body, which supported the idea that the animal was using a membrane as a wing. But researchers believe that this particular dinosaur didn't use flapping to fly, but instead used its wings to help it glide. And that's what makes this dinosaur such a critical piece of the puzzle, because it gives us a window into the early stages of flight. In fact, researchers think that it's so well preserved that it will help scientists determine how these dinosaurs moved through the air. And that is something that will hopefully tell us more about how these magnificent animals evolved. After all, understanding how these dinosaurs flew could reveal why they went extinct. Many scientists think that the mass extinction that killed off most dinosaurs also killed off most flying dinosaurs, along with all the giant marine reptiles, because it wiped out most flying insects, which made up the bulk of their diet. But the fossil record tells us a different story. The fossil record shows that flying dinosaurs continued to exist after the mass extinction, but they were noticeably smaller than before. And while this may seem like a contradiction, it actually makes sense if these animals were dependent on insects for food. the extinction of large insects may have driven the evolution of smaller dinosaurs. And this highlights just how much we still don't understand about the Jurassic Sky. These days, we share the sky with only one group of animals that's descended from the original flying dinosaurs. And thanks to their incredible ability to adapt, there are hundreds of kinds of birds on every continent on Earth. And while the story of the first flying dinosaurs is almost certainly different from the story of birds, learning about it will teach us more about the evolution of flight in general, and it will give us a better understanding of the world that our ancestors once inhabited. Thanks for watching this episode of SCI Show. If you would like to help support this channel, you can go to our support page.